Welcome back, dear students. Today's topic for discussion is laboratory preparation of aniline. And aniline is the common name. Its IUPAC name is benzene amine. So in the lab, aniline can be obtained from nitrobenzene. So you can see this aniline being obtained from nitrobenzene, but it has to be reduced. This Sn plus HCl is the reducing condition. So this two combination generates this nascent hydrogen. Now this nascent hydrogen is responsible for reduction of NO2 group to NH2. Okay, so this is the laboratory preparation, and this is reduction of nitrobenzene. Now this aniline, since we have discussed aniline, it acts as what? It acts as base. Therefore, it reacts with acids to form salt. Okay? So whenever aniline reacts with strong acids, HCl is a strong acid, what will happen? It will always form salt. You know, in small classes, in your lower classes, you have learned when acids and base react, they give you salt. Here also, the same salt is produced. So, this can be written as, since this contains lone pair, it will abstract this hydrogen, therefore, it will stay as NH3 plus, and now this is Cl minus will come nearer to it and stay. Okay, and this, whenever you have cation and anion together in one compound, then that is salt. This can also be written as NH2 dot HCl. Okay, similarly, whenever aniline it reacts with, say, sulfuric acid. It reacts with what? Sulfuric acid. So here also it will result in the formation of salt. So you will be getting NH3 plus, and since the valency of sulfate is what? 2, this entire thing will be twice. SO4 2 minus. So this plus charge, instead of writing here, you can write outside the bracket. Okay? So, simple reaction. Base, this is acting as base, reacting with acid to give you salt. So, the next topic for discussion is alkylation. So in our previous video 2 we had discussed about alkylation, acetylation. So here, since we are discussing about aniline, let's write this reaction once again. That is alkylation. Alkylation is a first degree amine. So whenever first degree amine, NH2, this is aniline, it reacts with alkyl halide, say CS3I. Since I have already shown you the mechanism in our previous video, here I am going to write the product directly. This will be bonded with this one iodine, and one hydrogen will be eliminated as minus HI, and here you would be getting NH, and this CS3 group would be attached to nitrogen. Now this is second degree amine. Now this further reacts with CS3I, and again here HI will be eliminated, and you will be getting tertiary amine, that is CS3. This is third degree amine, Now this further reacts with CH3R. Since it has lone pair, it gives us N2 plus 1, 3 CH3 whole thrice. This now becomes positive, and since this I is present, it stays near to it as I minus. This is first degree amine converted to second degree, third degree, and this is quaternary. Okay, so this is alkylation. Now let's discuss about acetylation. Acetylation also we have discussed in our previous video. So let's write this reaction of acetylation with aniline. So acetylation. So aniline, whenever it reacts with, say, acetyl chloride, CH3, CO, Cl. Okay? In presence of some base, say pyridine, this will act as a catalyst. Now what will happen? This nitrogen, this one hydrogen and one chlorine from here will be eliminated as minus HCl, and you would be getting this product NHCOCH3. Okay? This product you will be getting, and the name of this product is N-phenyl acetamide. N-phenyl acetamide. Okay? Similarly, the next topic is benzodylation. Now you can see acetylation and benzodylation is almost similar. Instead of CH3, here you would be having what? Benzene ring. Okay? So here aniline reacting with, see, benzene can be written as C6H5 COCl. Okay? This is benzoyl chloride. The name of this compound is what? Benzoyl chloride. Therefore, let's see now. The reaction would be exactly the same. Just in place of CH3, what happens? Benzene ring. Okay? So here, one hydrogen and the Cl will be eliminated as HCl here, particularly. Then you would be getting this compound where now this CO will be attached to this nitrogen, that is COC6H5. Okay? So the product is very simple, and its name is N-phenyl benzeneamide. This is N-phenyl benzeneamide. Okay? So the next reaction is carbylamine reaction. Carbylamine reaction. So this also we have discussed before. So this is given by only first degree amine, and here NH2 attached to the benzene ring is what? It is first degree amine. And whenever this reacts with chloroform CH3 and alcoholic QOH, what will happen? This will be converted to isocyanide. So we would be getting N111C. So this is vinyl isocyanide and the byproducts are KCl and water molecule. So here, if you want to balance it, 3, 3, 3. Now this equation is balanced. So I told you this carbyl-amine reaction is given by only first degree amine and can be used as a test to distinguish between first degree amine from second degree and third degree amine. So this reaction is very important, and the characteristic smell that you obtain of isocyanide is what? It is offensive smell. It is very unpleasant. Okay? Now, the next reaction is dioxidation reaction. The first chapter of your organic section. We have discussed dioxidation reaction there. So, dioxidation reaction. So in dioxidation reaction, aniline, whenever it is treated with HNO2 and HCl, and the temperature, it has to be between 0 to 5 degrees centigrade. Okay? What will happen? This will be converted to benzene diazonium chloride. That is N2 plus Cl minus. Okay, this is benzene diazonium chloride. And the byproduct that you obtain is it's 2 molecules of water. So this benzene diazonium chloride, okay, we can get it from aniline at very low temperature. Please look at it, 0 to 5 degrees centigrade. Whenever you treat aniline with what? HNO2 and HCl. Okay? Now, let's discuss about electrophilic substitution reaction in aniline. Electrophilic substitution reaction. Electrophilic substitution reaction. So, electrophilic substitution reactions, we have discussed about electrophilic substitution reaction so many times in our previous video. Actually here, what you have to know is NH2 is what? It is electron donating group. So once it donates electron towards the ring, then what will happen? Resonance takes place, and as a result, what will happen? See, here negative charges will be coming here at ortho and para position. So whenever some electrophile is there, say electron loving group, that means it loves negative charge. It gets attached to that place where there is more density of electron. Therefore, it can come and get attached at para position, or it can come and get attached at what? Ortho position. Therefore, this aniline is what? It is ortho and para directing groups. Okay? So don't forget this. Whenever you have electron donating group or electron releasing group like this, then they will always attract the incoming electrophile either to ortho position or para position. Okay? Now, here this NH2 is what? Electron releasing, means it is activating the ring. It activates the benzene ring so much that mono substitution. I hope you understand by mono substitution. Mono substitution means, say, you have NH2 group and say any electrophile in general, okay? Now, mono substitution means since this is electron donating group, negative charges would be either at both at ortho positions and para position. So it could come at one place. Okay, that means say at para position. NH2 and this electrophile would be attached at what? Para position. Now this is mono substitution because only one of the places is occupied. Okay? Please listen to it now very carefully. Since NH2 group activates this benzene ring so much that you don't only get this mono substitution, but it gets converted to what? Say now, this is mono substitution. Now because NH2 group is so much activating group that the incoming electrophile would come at all the three positions, that is ortho positions and para position. Okay, and you can't usually stop the substitution just at mono position. Mono position means any one occupied. Usually what happens? All the three ortho as well as para positions will be occupied. Now this is a problem for us. Okay. Now if you want to prepare, say just one product, say instead of this, you want to prepare only mono substitution product here. Okay, this. Then what should you do? You have to decrease its what? Activating property. So how can that be done? That can be done by including some electron withdrawing group at this NH2. One of the hydrogen, if it is replaced by any electron withdrawing group, then this electron would not be going to the benzene ring. Okay? And that, in this way, we can get mono substitution. And for this, what we usually do is, whatever we have already discussed, that is acetylation. So for mono substitution, if you want to get mono substituted product, then what you have to do? You have to first protect this NH2 group by acetylation. And this is very important point. Okay, see what you have to do is you have this NH2, you have to treat with what? Acetyl chloride, CH3, C double bond O, Cl, obviously in presence of PDT. Now what will happen? You would be getting this product and H C double bond O CS3. Now see, let me rub this part so that it will be more clear. See, now this lone pair over nitrogen, what will happen? It is pulled by, see, it comes now in conjugation with this C double bond O. Therefore, now this is not readily available for taking part in resonance inside of it. And once that is done, that means here the electron density inside the benzene ring at ortho position and at para position would decrease. Now, in that way, we can just protect this NH2 group by acetylation. Now you carry electrophilic substitution reaction, you will be getting only mono substituted product. So you might be thinking, now since it has been converted to such a compound where such a big group is there, so how can you get rid back? Okay, how can you get rid of this such big group back to NH2 group? That is very simple. Okay, you just have to hydrolyze it. Now once you carry out mono substitution reaction, you protected this, you carried out electrophilic reaction. After that, once you obtained your desired product, then what you have to do? You just have to hydrolyze it. Okay? So if you hydrolyze it, what will happen? You will be getting back what? NH2 group. Okay? So, This protection is very important if you want to carry out what? Modal substitution, electrophilic substitution reaction. Now, first you protected it. Now, what you do? You treat with some electrophile, like we have done nitration, sulfonation, this halogenation. You carry that out. You get the modal substituted product. Once you get your modal substituted product, you hydrolyze it to get back what? NH2. Hope this is clear. Now, so let's discuss about the chemical test for aniline. Okay? So one of the tests I have already taught you so many times, that is carbon-amine reaction. So carbon-amine reaction, in carbon-amine reaction, what did you obtain? Now whenever aniline is treated with what? Chloroform and alcoholic KOH. Now this gets converted to what? Phenyl isocyanate, which has a very characteristic smell. That is very unpleasant, offensive smell. And from there you can tell that this compound is what? Aniline. So the first test number 1, carbon-amine test. So I told you this one. Number 2 is beta-naphthol test. So in this test, what you have to do? This is also known as what? Dye test. Now, one of the reaction on diazotization, you saw what did you obtain? You obtain benzene diazonium chloride. Now this benzene diazonium chloride, if it is treated with or coupled with alkaline beta-naphthol, then aniline forms an orange-red dye. It forms what? It forms orange-red dye. This it means after diazotization you obtain benzene diazonium chloride. Now that has to be coupled with what? Alkaline beta-naphthol. Now if you react them together, if you obtain what? Orange-red dye, then the compound is what? The compound is aniline. These two tests are very important. So this is the end of today's class. So we will see you again. Till then, take care.